Hello everybody and welcome to Science Week on Viking.TV. My name is Damon Stanwell-Smith and I am the Head of Science and Sustainability for Viking Expeditions. And this evening we have, we hope, what is a very interesting subject to discuss with two specialists in citizen science. This is very relevant to all scientific endeavour and especially to expeditionary travel. You may recall, for those that have been following Viking TV, that we had an interview in December with Olaf Orheim and Julian Dowdeswell discussing icebergs. And this is in the same vein of discussing with experts interesting topics that we hope that will inspire you to explore more. I'm now delighted to be able to introduce two friends and colleagues who are going to be talking with us this evening. Over to you, Laura.
Hi, I'm Laura Smith, and Damon, thank you very much for having us, as well as a big thank you to the whole Viking team. I'm here to talk to you guys about citizen science in the polar regions, specifically for me, Antarctica. But everyone always asks, how do you end up there? So as my intro, I thought I'd sort of explain a little bit about that journey. I'm originally from Washington, D.C., so far away from polar regions, but I guess I was destined to end up here doing some sort of exploring, as my high school desk was set up like an 18th century ship's captain. I adored Captain James Cook. I had a poster of his Endeavour over my college dorm room wall. My desk had quills, pens, old maps, and everything like that. So I was sort of destined to end up here. At Princeton, I studied geological engineering and studied more in the mountains. I was all over Mongolia, Morocco, New Zealand, and I even named a fault during one field season in Mongolia, the Jid Fault. After doing a quick stint in Vietnam teaching English, I spent 10 years on vessels around the world making 3- and 4-dimensional maps of the geology under the ocean floor. And then I also spent some time in Norway as a software tester, testing our software that we used on the vessels. And that is where I met my husband, who is a captain. So he was driving the big boats and I was doing the geology. And at that time, he was building his own boat, sailboat, and we sailed that sailboat, Quixote, to Antarctica in 2013 as our honeymoon. So we actually had to tell all of our wedding guests not to give us, plates and china and wine glasses, but rather they had to give us flare guns and charts and donate to the dinghy. So what you see there is actually a product of all of our wedding gifts. So thank you, all of our wedding guests. And in 2014, we started our own company, Quixote Expeditions, and we now have 2 boats, a sailboat and a ex-Norwegian life-saving vessel. And in addition to taking passengers, we also do a lot of science and citizen science on board. In addition to my own company, I'm actually very, very involved in sort of the greater Antarctic community at large. I'm very active in IATO, the International Association of Antarctic Tour Operators, which works for the protection within the tourism realm of Antarctica, as well as creating guidelines. And I'm the chair of the yacht committee. And the reason I'm here today is I am the chair of the board of the Polar Citizen Science Collective. And I won't dive too much into that because that's what we're going to talk about today. So before I go further into that, I'll hand it over to you, Damon. Thank you so much.
Well, I'm delighted, Laura. Thank you so much for joining us. And now I would like to introduce Allison.
Hi, everybody. Thank you, Damon. Nice to see you, Laura. My name is Allison Cusick. I am currently in San Diego, California, but originally from Seattle, Washington. And I'm very excited to be here today talking with you all. I'm a biologist by training, a marine biologist, an oceanographer, and I specialize in understanding the microscopic life forms in our oceans, in particular the polar ecosystems. And I am in San Diego because I'm pursuing my PhD at Scripps Institution of Oceanography. And there's really this big question of how melting glaciers are influencing these microscopic levels of life. So we'll talk more about that later. But as Laura said, how did I get to polar? I actually spent my early life avoiding the oceans. My mother had a traumatic experience with the ocean, and so I went into the land ecosystems for 10 years. And only later in life, randomly through a job I held as a technician in 2013, my boss came to me and said, I received funding from the National Science Foundation to go to Antarctica for a 53-day expedition, and I don't have the time to go, so you're going. And I had never been to sea. I had never been on a ship. And I had always thought I'd go to Antarctica as a tourist or a traveler. So for me, this was just a pivotal moment in my scientific career. This is the icebreaker we were on, the Nathaniel B. Palmer, with a team of 25 scientists, graduate students, technicians, and chief scientists. And it was amazing. As soon as I landed, I felt like I was on another planet. And I said, I'm going to dedicate my career to understanding Antarctic ecosystems and polar. And to kind of give you guys a flavor of what research ship life is like, I took a couple photos of the inside of the ship, and it's very different than what a tour experience might be. So also in the way we collect information about the ocean. So here you can see an image of the inside of the ship lab. So when we arrive on board, nothing is on these tables. We have to pack up all of our equipment months and months ahead of time, ship it to the port, and then it gets delivered to the ship. Then we arrive and we have to assemble and install everything. And of course, the key component, as you can see here, is this latte machine. Coffee during a long expedition is very important. And becomes a bartering piece later on in month 2 when you're running low on your chocolate and your espresso beans. So also, I wanted to kind of show you guys what it looks like to be working on a research ship, because we have huge pieces of equipment that we put overboard. And there's an image of a rosette of bottles. That is how we can collect information about the ocean. Going down to 4,000 meters. In this particular case, we went to 500 meters, and you can collect different segments of the ocean. And then each researcher has a different question that they're asking. So, you know, when you think about this, how do you translate all that to citizen science? Well, that's what we will get into.
Fantastic. Thank you and welcome, Alison and Laura, of course. I feel in your presence, I should just maybe touch on a couple of points of my career that may be relevant to our conversation too. It would be self-indulgent for me to give a full intro, given that I had that opportunity last August on Viking.TV discussing with Jørn Henriksen our careers to date. I just want to dwell on 4 words that may come up in our conversation that have shaped my career around citizen science. Firstly, stigma. That in the early part of my career, I worked for an NGO called the Society for Environmental Exploration, running expeditions in East Africa and Southeast Asia. And one of the issues there was having non-specialists do work. At the time, in the sort of 90s and early noughties, there was a bit of a sense that professional scientists felt that non-specialists couldn't really do science. And I actually found that quite challenging as a sort of science leader within that. From inspiration, as the next term I'd like to bring up, is that I spent late 90s, early noughties working both in sort of leadership of science, but then also working as an expedition leader on an expedition vessel. And it was very inspiring to see guests excited about the natural world and wanting to engage in science. Thirdly, big data. Now, I'm sure that Alice and Laura have views on this later in our conversation, but I also spent 6 years at the United Nations Environment Programme's World Conservation Monitoring Centre. And the importance of citizen science data in informing biodiversity-related issues, especially tracking it for informed decision-making, became really apparent. And then in the present, as we sit here and we're planning what we're doing with Viking Expeditions in the near future, how the world has changed in terms of acceptance of citizen science data. And indeed, I know that's going to come up as well. And how exciting it is to work with Polar Citizen Science Collective, with Cornell Lab of Ornithology, with NOAA, with Scott Polar Research Institute on ways in which our guests will be able to engage in citizen science projects in the near future. So looking forward to the conversation. And if we were to start by reflecting on how to define citizen science, I wondered if we could start there, just so that we're on the same page of what we're all talking about. Alison, would you have a view on this?
Yeah, so basically citizen science, it can also, go under the names of community science, volunteer monitoring, public participation in STEM research, but the fundamental definition is that it's a form of collaboration in which the non-science specialists and individuals can participate voluntarily in the scientific process, and that covers a number of ways people can be involved, if it's from helping design the research questions or creating the project, conducting experiments themselves. Some projects, they can help analyze the data, interpret the results of the data. There's a huge spectrum of ways to be involved in science, and so citizen science is that effort to bring together more people in the scientific endeavor.
Oh, fantastic. And Laura, did you have from your Citizen Science Collective perspective, any other things to reflect on?
Just a few things. I mean, our own definition is that citizen science is the collection and analysis of data relating to the natural world by members of the general public. So basically anybody can do it. And then it's usually in collaboration with a professional scientist. So that data that you and me collect, we collect, then actually goes to somewhere to then analyze it. And I also think something that's really important with citizen science is that it's not just like one thing, it's a really broad spectrum. And so some citizen science projects might only involve a few participants or just a school. Some citizen science projects might be global. Some citizen science projects require zero training, whereas others might require, a few hours of training to be able to go out to do it. But what they don't require is that we all have PhDs. And so I think that's really the important part, is that everyone, if they have an interest, can participate.
Oh, fantastic. And there's also, my understanding actually, Alison, in preparation for this conversation, I understand that even the term citizen nowadays sometimes carries a sort of maybe an ambiguous connotation in some discussions. I understand that you had a recent experience of that. How do you address the sort of citizen side of citizen science?
Yeah, that's a good question. I mean, it's definitely, terminology is important in what you call things, and especially in the case of citizen science, it can generate how we think about collecting knowledge. And so in some situations, citizen can be a little polarizing, but it doesn't mean that you're a citizen of a country or a nation. That was never the intention. It was a citizen as in the sense of having the right to be a part of the scientific process. So I think the terminology is important depending on where you are in the world conducting science and knowledge learning. But in this case, it's really place dependent on what term you use. So
yeah, so for the purposes of this conversation, citizen science is everybody getting involved in the broadest endeavor. And indeed, something that I often, when talking to people about what science is about, refer to the fact that in biology is just applied chemistry. Chemistry is just applied physics. Physics is just applied maths. Maths is just counting. And so citizen science really, when it comes to anything to do with the outside world, is just counting. You can count when you're 5 or you can count when you're 95. And that maybe demystifying some of the elements of that is also part of how to engage citizens too. And noting that Laura, you mentioned about that spectrum of projects. How do you cover that in the Polar Citizen Science Collective? Is that part of the criteria that you look to bring different projects on?
Damon, before I jump on that question, is it okay if I dive a little bit more into what the Polar Collective is and just give a little bit of a history of it?
No, absolutely.
Perfect.
Absolutely.
Perfect. Okay, great. So, we've been talking about the Polar Citizen Science Collectives, stuff at the poles. Like, what are we even talking about here? So a bit of the history of the Polar Collective, and I can even talk from personal experience. I told you about when I went on my honeymoon to Antarctica, and here I am, this geologist, and I want to do something, right? Like, I don't just want to take pictures. So I reached out to all of my scientist friends, all of my professors, kind of everybody, and they were all saying, oh yeah, that sounds great. There's got to be a great opportunity. I'm sure you can help collect data. And then nothing. So, I reached out again. Any follow-up? Do you hear about any opportunities? And I was contacting, like, nothing. I couldn't, everyone's like, no, nothing came up, sorry. So I kind of gave up, and then thank goodness for Facebook, I saw something pop up about an opportunity for citizen science, and I actually was able to jump on that. But that was after hours of frustration of looking for something, anything. Like, here I am, I want to do something, and I can't find it. Meanwhile, on the expedition ships, many guides were having exactly the same experience. And because many of the guides have backgrounds in the natural sciences, like they wanted to do something, maybe they were finding a project, maybe it was working, maybe it wasn't. And then as they were finding projects, they realized, wait a minute, like everyone is struggling together. Let's come together. So in 2017, 5 guides came together and said, let's take everything that we found so far and let's share it with the rest of the polar tourism industry so they don't have to struggle like us. And so that is kind of the origin of the Polar Collective, is like, let's share about projects that are out there. And today we're expanding a little bit more. So when it started, it was let's find projects that happen to work on polar ships. But now we're also working directly with scientists who really need data in the polar regions to make their projects work on the expedition ships. So we're really growing in scope, which is super exciting. Any questions about that, Damon, or is that good? Do you want me to jump into a project?
I think that's great to explain, and my apologies for having jumped straight in. But one of the ways maybe to explain is to give examples. And so if we were to illustrate for viewers ways in which citizen science can be engaged in a polar context, we could discuss some case studies here. So I understand that we could start with one from NASA that is within your portfolio.
It is. So one of the early projects that's still going strong within the Polar Collective is the NASA Globe Observer Cloud Program. And apologies if I don't say all of those words every time that I refer to it. So first off, it's cool because it's NASA, right? So just keep in mind, all of the data that I'm going to be talking about is going to NASA, right? Like, not going to someone's second grade project, it's going to NASA. But to contextualize it, like, first, why do we care about clouds? Because I hope that you guys can lead with a little bit of something and not just know that we're doing something. We care about clouds because they really impact the weather and the climate. Clouds can do a lot of things, like they can hold heat in, like a blanket. They can also reflect the sun and keep heat out, like a mirror. They can also help to transport heat. So clouds are super important, other than just being pretty, in terms of how we understand our climate and then how do we predict it. So that's why clouds are important. So now we need to know about clouds, right? If we want to be able to understand our climate. So NASA has a lot of satellites, and satellites are great. Obviously, they can cover a lot of area. Some satellites have really broad scopes, broad bandwidths, and can see a large area. But generally, when they do that, they might lose some detail. Some have really narrow scopes of detail, and so they maybe need to fill in the gaps. And also the satellites don't say, oh, there's a cloud, right? All they do is like see a wavelength or bounce back and might get red dots or green dots, right? And then you have to learn what that actually means. And if you think about it, the satellites are also above, so they can only see like the top part. So maybe there's something different happening on the bottom. So that's why you need essentially ground truthing. You could have stations, or you could have people scattered all over the world taking these photos. So if we could just have that, well, we have a first photo of Antarctica and then a quick photo of some people looking at clouds. So what the NASA Globe project does, so there's just there's Antarctica, and you can look at the clouds from there. This would be a fairly cloudless day, except for a few in the distance. And if we can go to the next slide. So what the project does is that it has you and me, children, school kids, tourists. You go out, and when you know the satellite's passing over, because there's a schedule, you can take photos of the clouds. So you go north, south, east, west. You do the horizon. Maybe the next slide, you can watch everybody doing it. And then you also say, oh, today was a 100% cloudy day, no blue sky. Or you say it was a perfectly blue sky day. Or you say it was 50%. So then what NASA can do is they take that observation plus another observation plus another observation, and they can actually start to, quote, ground truth or better interpret what these satellites do. And again, you might say, oh, what's little old me taking one photo? But that's a data point, right? And once you get one data point plus 2 data points plus 10 data points, that's a data set. And then you're talking like real data to work with. But you need to start with one data point and then grow on it. And so I just think it's really cool because this truly is global. It's working with NASA, and almost all of the data points currently collected in the Drake Passage and Antarctica are from the passenger expedition ships. So with the growth of the Polar Collective, their data collecting abilities have greatly expanded in this region of the world.
Yeah, I think. Can I add one thing I also love about this which is what's significant for the polar regions, is Laura showed a beautiful image of a cloudless day, but Antarctica and the Arctic, like globally, they are the most cloud-covered regions on our planet. So understanding what's happening underneath those clouds has been very difficult from a remote sensing perspective. So that's also why the NASA Globe project is so awesome, and that, the ground truthing those data points while you're in the polar regions looking from below.
Yeah.
And
also, yeah. Sorry, Damon. Yep.
No,
sorry, Damon.
no,
go ahead.
Right.
No. Go ahead. We don't need to talk more about clouds. Go ahead, Damon.
Well, it's related to clouds. Is how frequently do the satellites go around? So is it pretty frequent? Is it once a day, or is it multiple times a day, or?
Ooh, Allison,
I know there's I think the A train is a series of satellites that follow each other in a polar orbit. So it's 12 hours. Every 12 hours they reach the different sides of the Earth. So they're capturing in constant, like a lawnmower going around the world.
Yeah. And I guess it's just a smartphone picture and job done.
Yeah, exactly.
Well,
exactly.
And photography is often used as part of citizen science, and with the modern cameras on our phones and similar. I understand the next case study you're keen to highlight also involves photography, and that's is Happy Whale. So that's the next scale up in terms of photography.
It is, well, the next scale up. Yeah, no, it's great. So the other project I just like to highlight, I highlighted NASA because I think it's cool that we're working directly with such a well-known agency. But then I'd also like to share about Happy Whale, because we always talk about, data and policy and something like that. But what does that mean? So with the project of Happy Whale, basically most whales, and especially humpbacks, can be identified by their tail. And historically around the world, there might be databases at this institution or that institution. But then one of our Polar Collective members, Ted Cheeseman, realized that, wait a minute, we have all these passengers going to Antarctica, and they're going because they want to take pictures of whales, right? And so you have this huge potential of all of these whale tail photos that are just sitting on people's, little photo cards and probably not going anywhere. So we can use all of this for science as well as to get them more interested. So in 2015, Happy Whale was born. So that when you or I went down to Antarctica, or actually Happy Whale is global, so if you see a whale anywhere, you can upload it. And so you upload your photo, you put the GPS point, and then the cool thing is that if someone else uploads that same whale, that you get an email saying, oh, this whale was seen. And I've had my whale. I've had a whale that I photographed pop up, 10 miles away, 20 miles away the next year. But I've also had a whale pop up in Panama that I photographed in Antarctica. And so that just gets me excited. So I hope it gets everyone else excited as they, get this feedback. So that's one really cool thing about Happy Whale is you get this constant feedback and it keeps you interested. But the other interesting thing is that it has influenced some policy. So within IATO, the tour operator trade organization, in 2019, they looked at the data. They used the data from Happy Whale. And using this data, basically they realized, there's a certain time of year. So it's not necessarily the whole Antarctic season. It's later in the season. There's a huge congregation of whales, and we know where they are because it's not necessarily everywhere. They like to go certain places. So with this knowledge, IATO was able to create an area, and all of the tour operators have agreed to go slow, go less than 10 knots during a certain time of year in this area to reduce the risk of whale fatalities. So without this data, this would not have passed because it would have been too up in the air, right? What do we do? Where are we going? But we have data so we can make decisions. And I think the goal of a lot of the data we collect is that it can be used to make either better decisions or even to make decisions at all if we haven't had data previously. So citizen science, your whale tail photo, again, is part of the data set that then goes in to make this decision, which I think is super cool.
I love the connection. And can I pick you up on a point you said, my whale, when you took a picture? To me, that is the essence of citizen science, is that your personal involvement with that data point and how that expands is that I think it's the collective experience of anyone engaging in citizen science, whether they're counting birds in their garden or whether it's whales in the Antarctic and taking pictures, is that you feel personally connected to the decision that's subsequently made.
I have a whale too. I saw it was missing half of its fluke in Antarctica and took a picture and called it. I got to name it Port for port side. It's the part of the tail it was missing, and then it was later spotted in that season, and then I haven't gotten a notification that it's been seen since. So
they say,
Port, what's happening?
No, I think it's a really powerful connection. And noting Laura's comments earlier about the continuum of very simple things through to more involved citizen science. Our third case study, I'd invite Allison to share the work that you're doing.
Yeah, so this is an example I'm going to talk about that's probably on the more involved end of the spectrum of citizen science projects, because there is some training that is required. So same sentiment as Laura. When I first went to Antarctica in 2013, I went as a scientist, and I learned the place is preserved for peace and science, and also learned about, each of the buildings on the continent are research stations. And so I learned about this tourism industry and thought, well, there's people that are coming down to travel here. They're 5 months out of the year. You have polar guides and tour operators that are pretty much like local inhabitants, if you will, as an analogy to nobody lives in Antarctica as an actual resident. But that's a huge opportunity to engage that community in the efforts of doing polar science. And so as I was thinking about going to graduate school, I was thinking, how could I, combine these two worlds and basically bring science to the people and get people involved in science, because I think it's really cool. And so hopefully that, my own motivation is transferred to the experience other people have. And so, there is a project, Fjord Fido. So one of the things that is lacking in the information that we have about, in particular, the Antarctic Peninsula, is the coast. There's, some efforts from research stations to monitor annually what's happening on the coast. NASA would love to use remote sensing to monitor what's happening in Antarctica and get to the scale of the coast. And then you have ship campaigns that go down that take measurements. So in this sense, Fjord Fido is an effort to train polar guides that work on the ships how to do like basic oceanographic sampling in a user-friendly way with equipment not like what I showed in one of the earlier images, but easy stuff that can just be thrown over the side of an inflatable rubber Zodiac boat. And then you pull up some of that seawater with a net and show people on board. You know, you can drop, in this case, is a Secchi disc that's one of the oldest oceanographic pieces of equipment. I think it was in the 1800s on the Challenger. Gentleman threw over a dinner plate and waited until it disappeared. And that was a translation of how much light could reach through the water column. So just what measurements could we get in a user-friendly way that would help us learn something about, in particular, phytoplankton on the coast within all these fjords and how that is being influenced. Here is some phytoplankton. It's a really rich community, particularly called diatoms, kind of rule the system down here. But how is the melting glaciers on the peninsula influencing the community of the microscopic life, which then feeds, you know, these whales and seals and penguins that live down there? So Fjord Fido's attempt is to cover that 5 months of the season, and then every year that ships are down there. And it's engaged over 3,000 people, hands-on, have been able to actually collect data points. And it's all, of course, thanks to polar guides and you know, tour operators having the interest, much like Laura being trained to take it. And so it's a huge help, and it takes a community effort. And so yeah, also, I think there was another photo I could share of what happens after the process, because, you know, you have what's going on in the field and travelers helping collect the sample. And then all of those samples get sent back to me in San Diego through a wonderful logistics dance. And then this is showing all the tubes that have been collected. So all of those filters of green phytoplankton have been rolled up like a burrito and stuck in the tube and preserved until I'm able to extract the genetic information. That's one way we can understand the microscopic level of life, is through the genetics. And then also my colleague, Martina Massioni, is in Argentina, and she is a traditional taxonomist. So she can look under high-powered microscopes and actually identify individual species based on what they look like. And she can also see if, in this case, you're looking at a beautiful glass diatom next to the black and white image of a type of phytoplankton that loves fresh water. So are we, you know, what shifts are we seeing in the type of phytoplankton? Are we seeing the smaller cells that love fresh water? Are we seeing these big cells? And so kind of marrying all of that information together has been really fun and an awesome way to do science and engage the public and the travelers that come down there. So,
Allison, can I make a comment on your project?
Yes.
One thing that I love about Allison's project, and when I talk to either my own guests or when I talk about the Polar Citizen Science Collective, is, you know, Fjord Fido, it needs data, as she said, over 5 months, right? So from November until March. And it also needs data over multiple years to be able to look at the change in a season and the change in years. But usually, like the ship that Allison went on for 53 days, they might just do one transect. So like, boom, you go one place on one day and you have to collect all your data in that place, but you never go back again. So it would be impossible for Allison to get data from the same place over multiple months, over multiple years. But oh wait, we have passenger ships that are going to the same places over all of these months, over multiple years. So you have this tool that is a tool like the passenger ships, and her project isn't possible without this continuous presence and continuous sampling. So I just think that's really cool that we get to know more info that isn't otherwise possible.
Yeah. Well, oh, sorry, Damon, do you want to jump in?
No, I was going to echo Laura's comment that longitudinal studies in time are very well suited to ships that go to the same places every year. But no, do carry on with your reflections on Fjord Fido, please.
I was just going to make the additional comment that I think it was the very first polar conference, staff conference I had gone to where I met Damon in person. Laura, I think I had met you. I had met you through email before that. And Damon, you made the comment that, to be science still has to be published in scientific journals. And so that's the difference between just being a purely educational activity and then a scientific, with the scientific angle on citizen science. And another way is through social media. So instead of just having knowledge produced in these highly specialized journals that often have paywalls to get access to, social media has been amazing in relaying the information we're finding and sharing photos and sharing the experience with people who might not necessarily be able to go to these regions of the world. They can still learn about the projects and what's going on because of Instagram and Facebook and Twitter and all of the platforms that are out there right now. So especially for Fjord Fido, as a scientist, we're learning science communication skills and how to bring that information to those platforms to be accessible, so that people can, know what's going on as we're collecting that information, not years later after we've published it in a peer-reviewed journal article.
And on that, Alison, at the risk of embarrassing you, as Laura and I both know, I feel that you are preeminent in influencing in this sphere. And as you point out, the power of communicating in the social media and this new way in which the world communicates, how we've seen it can work for good and ill. And certainly this is very much the power of the good. When you say that you've had 3,000 people involved, I think of each of those 3,000 inspiring others within their social circles and professional circles. And I absolutely concur that this is the way that information should be disseminated over and above the sort of the classical ways of communicating through primary literature. I wonder whether at this point we could continue our conversation and reflect on how citizen science has become accepted, because the examples you've given to me all give very contemporary ways in which these data are informing decisions, if you like, the power of the crowd. And I wondered if you had any thoughts on how that's changed even in the time that you've been involved with citizen science.
I'll start on something, and then Allison, you are even more involved in this than I am. But I think one thing that Allison said, which is really important, is that sometimes citizen science is viewed as purely an educational fun activity, when really it's twofold. Like for the Polar Collective, we don't want to do a project that is purely like, we don't want the data to get thrown away. Like, oh, I'm scooping up water for fun, right? No, that's not the point, to scoop up water and look at it and then toss the data, behind your back. The goal is that it's educational, but it also has true data value. So I think one of the challenges is getting scientists to realize that, we are doing real, like it is real data and it's not just for fun. But I think some of the things that have helped with that is that there's first just been more of it, right? So the more you have of something, the more it can get accepted. But also the growth, it sounds dumb, but like the growth of smartphones has really helped, because, your smartphones have GPS. So when you use an app, the Polar Collective as an app or the cloud app, your GPS is automatically there. You can really step a user through what you're supposed to do, which is sort of like a bit of a control. And then the data can get uploaded, because let's face it, if it's on paper, if you're in a Zodiac and it's cold and it gets shoved to the bottom of your backpack and then it's wet and then you can't read the pen thing that you wrote, like, goodbye data. So I think just more of it, as well as smartphones, has helped a lot in just terms of the growth of it. What do you think, Allison?
Yeah, I definitely agree with that. It's just, I think because of smartphones too, and realizing the power of the crowd, informing our knowledge about even weather patterns has been really important. For me, it struck home. So when I was designing this project, I went to a polar science conference and I shared a poster of the idea, what do the scientists think of this idea? And there was some of the attitude of, well, how can you have non-specialists be doing this? And so, you know, I walk through, well, there's protocols that are tested out. There's ways along the collection to validate the data that's coming in. And if you can throw out data that looks weird. And then I went to the, you know, Polar Staff Conference. Does anybody even want to do this project? Kind of building the capacity there. And then I went to the Citizen Science Association conferences, like how do you even design projects? And at that conference, I saw program officers from every federal agency, NOAA, NASA, USGS, NSF, all of the federal agencies in the United States were present. And for me, that was like, okay, like if they're funding citizen science, it has legitimacy. And that actually, my advisor, Maria Vernay, and I wrote a grant to the National Science Foundation and received funding to kickstart this whole project the first year. And some really exciting news I just learned about is our second attempt. We just received funding from NASA to bring it home to NASA's interest in monitoring Earth systems from remote satellites. They also want to see through the clouds so they can see ocean color. And ocean color can be detected with the phytoplankton, that green golden color phytoplankton give off. But also, is there an ability to detect the melting glacial water that's in the fjords and on the coast? So that is brand new.
That's very exciting. Congratulations.
Yes, thank you. But to make the point that it's accepted, and there are standards and ways to do it properly to make really good science. So,
no, I think that's the point very well taken. In fact, James, to build on Alison's point there, could you bring up the slide on the National Academy of Science reporting? Thank you. So just, and in fact, reflecting on Alison's point about the US federal agencies turning up to citizen science conferences to both fund and sort of learn more of what's possible. This report was published in 2018, and we've put this up actually just for those Viking TV viewers that would like to delve more into sort of the current thinking about citizen science and how it works and the learning on it. This is quite a substantial report, so this is for the super keen. The URL is there on the screen. And for me, again, I make this, I had that same reflection that when the National Academies of Science, Engineering and Medicine are putting together substantial groups of specialists to reflect on how citizen science can inform evidence-based decision making, you'll see these 4 points. I think this ground truthing, as Allison has mentioned, is such an important part of any sort of remote surveillance and satellite surveillance. Laura's point of when you get more and more data points, you're more likely to detect rare events. I think anecdotally, quite a few of the strange and more interesting wildlife behavior events have been seen by tourists in the Antarctic Peninsula rather than the few professional scientists that have been based there over the last 30 odd years. The quality of data on the impacts of natural anthropogenic forces. So again, broad data, where we're all learning about how powerful big data are. And I think it's also about innovation. I have learnt over my career that it's not scientists that necessarily have all the good ideas of how scientific endeavour should be undertaken. And more as I progress, I find the polymaths and the lateral thinkers are people that have chosen careers other than maybe the rigid structure of empirical science. So for all of those reasons, and this, of course, this report covers this very well, we are on a cusp of maybe a new way of engaging in how data are gathered for understanding scientific endeavour. And if we were to sort of move on from the present to the future, do you have reflections on what might be? This is just your thoughts on where we might be going, what maybe the Polar Collective might be thinking of in the next few years, or where Fjord Phyto might be beyond supporting NASA, and what's the next big thing, do you think?
Well, the next big thing, I mean, I think this is sort of just the growth and kind of continuation almost of growing acceptance of citizen science. And so I have one comment on that, which then moves it into the future. And, I think historically scientists have been a bit protectionist of like collecting data, but the reality is like there's a lot of data collecting that's not hard, right? Like I can snap a photo, I can scoop up water. I mean, I can't do DNA extraction. That's what Allison does, right? That's why she's getting a PhD. But there's a lot of data that's just not hard to get. So for me, I think we're really opening up this amazing use of resources. And the other is we live in a data-driven world, right? It's all about data this, data that. And so as we grow the strength and acceptance of citizen science, I mean, before, I don't know how many scientists there are in the world, but okay, a certain percentage of the world, small. But if you suddenly open up the resources to like every person living on Earth, then who can potentially collect data, I mean, that's huge. And so for me, that's the huge potential. So if more and more can, quote, jump on the bandwagon, then that's kind of what it's all about. And then also on the flip side, Damon, we were talking about my whale and how I personally connected. I mean, that's the other bit is that, with citizen science, it's not just let's listen to a webinar on something. Like people are doing something, right? And you're physically participating in the act of science. So if we look in the polar tourism world, when I when I do fjord phyto, or let's say another passenger does fjord phyto, some wonderful 71-year-old woman, and she goes home. And what usually happens? They all go to their, second grade grandson's classroom and they show these cool photos of penguins and icebergs. Well, if instead of sharing those photos of icebergs and penguins, you can say, here's a penguin, but let me tell you about what it eats. It eats krill. And krill eat phytoplankton. And then there's this whole food chain that I learned about. Let me tell you about that. And that's just one story. So you can imagine every citizen scientist telling stories and sharing the good news of science. That's a huge web of people getting involved. And that's just science literacy. And that's, that affects change going forward. So I think that's the really exciting thing for me is growing what we have to then go stronger within the data itself and then stronger within the human aspect of understanding.
Absolutely. Maybe they were saying, that's my penguin. I do feel a sense of ownership is essential to how we protect things, but it is exciting. And it's how about fjord phyto? Do you see beyond NASA? What's the when you've solved all of the truthing for Landsat 8, what's the plan beyond?
The plan beyond. So this is interesting because you never know with basic research where it will lead. There's a lot of cool stories of research being done 40 years ago that was just vacation science and is now why we have, the way we are able to do a lot of experiments in the lab. So hopefully there are some even uses for this that I'm not aware of, but to follow up on what Laura was saying, definitely one of the highlights for me personally too, especially when you're back, your experiments aren't working and you're just feeling the depressive side of science. I reflect on the kind of the comments that I've heard personally from participants, but also, when we ask people, is this enriching your experience? Is it enjoyable? Are you learning anything? Do you feel empowered? Many people, so we have some, surveys we do that they respond in a positive way. And the best moment is when they look under the microscope back on the ship and say, that's what's living in the water. And you're like, yeah, that is phytoplankton. But without the microscope, that connection would never be made. And so I've had specific quotes from people saying, this is the first time in a long while I felt that childlike spark of curiosity, or it allowed me to be more than just a tourist and gave my vacation a purpose. And it felt good to contribute. And then, some people also reflect on the fact that it helps them become more aware of the connection of Antarctica to our entire world, or from the Arctic to the rest of the world, that these aren't just remote regions that are going to melt and goodbye. Ice. They're instrumental to how Earth operates. So I think having those anecdotes of the participant experience is awesome. And that 71-year-old woman can go back and also say, I helped collect a sample. So I think it ties it all in. Also, there's, the efforts at a global scale with the United Nations Ocean Decade. So this is really exciting. In the next 10 years, the nations of the world have agreed to focus on ensuring that ocean science can support countries' actions to sustainably manage the resources in the ocean. And I think, citizen science provides that with data. Even if it's a regional, it can inform global decisions and also inspire people like you were talking about, Damon. Who do you know that's on that trip that experiences that and goes back home and tells their whole network?
Well, I think it's very timely, isn't it? And in fact, if at the risk of just making a specific point about Viking expeditions, in other broadcasts, I have commented that our vision is to reimagine what a ship of opportunity can do. Viking vessels, just as with maybe the way that the evolution of the ships of the world to gather information in order to inform our understanding of thank you, James, of how the world looks after its oceans. And in fact, at this point, I'd like to invite to some, if there's any anecdotes, but I'm going to share one to start with that is, if you like, almost like a cautionary tale in the light of what we're discussing about ocean decades and so on. I had the opportunity in my career to work, as I mentioned at the beginning of this conversation, with the UN Environment Programme's World Conservation Monitoring Centre. And in 2011, I was involved as one of the many coordinators of producing the flagship report for the UN environment. It happens every 5 years, and this is the UN's assessment of the entire world. And James, if you wouldn't mind just posting the picture of the front cover. Now, for our viewers, you'll see that as we have been discussing quite a bit of Antarctic things, and we know that's to the south, this is the front cover of a global report. And in the course of my work, I saw the front cover and had reason to ask those in leadership, what's happened to the Antarctic continent? And there was a real nonplussed look and a kind of realization. I imagine missing out any other continent. And the serious point is this, is that, as Allison mentioned, there is no permanent population living in the Antarctic. And so arguably there's no champions. And championing or being an ambassador for places, the remote places, which expeditionary voyaging gives that opportunity. But then to take it further is when taking on citizen science, as Allison and Laura have highlighted, that you get a personal sense. And I would argue that if there were citizen scientists who are going to these remote places, going specifically to the Antarctic continent, there is no way that when returning to their home life, as scientists or indeed any other discipline, would forget to put the continent on a front cover of a global report. And it's one of the dark points of my career, although I personally had no hand in the layup of the front cover, that it's a cautionary tale that I really feel that citizen science connects people to decisions, and something as monumental as this. This was the flagship report, I have to reiterate it, of the UN about the environment for that time. I hope 2021 it wouldn't happen again. But going on to anecdotes and sort of to maybe reflect maybe on the lighter side, I'd invite both of you, if you had any things to share with our viewers that maybe the lighter side of citizen science. I know that Laura, you might kick us off.
I do have one that I like to share because it goes back to the storytelling and the power of doing the science as well as sharing your story. So early on, so in 2013, 14, 15, just kind of on privately, we were involved with taking water samples to determine the amount of microplastics. This was aimed at sailboats around the world. And so we were mostly sailing in Antarctica, the Falkland Islands, Beagle Channel, the coast of Argentina and Brazil. And the cool thing is we were some of the few only data points in that area. So again, bringing data where there wasn't any. And so then we had sailed up to Rio and we were visiting some family friends. So James, if you can pull up this photo of Rio, just so I can set the scene a little bit here. Okay, so here we are in Rio, right? It's hot, there's beaches. We'd spent the day at the beaches and we were sitting at a restaurant, and I'm pretty sure this is the view from the restaurant. I went back and looked at my photos, right? So here we are, 2015, having dinner with my family friends. And these are well-educated folks. And so I was telling them about, oh, we're doing this microplastic thing. And let me tell you about microplastics, right? Well, microplastics are, they could be larger plastics that break down into smaller pieces. They could be from like your facial washes that have the little beads in them that are plastic, or, you could get microplastics in the ocean from your fleece jacket. And then I went on to explain how we did the sampling, how, we scoop up some water, we do this, we do that. And then our friend said, hold on a second, wait a minute. Again, remember we're in Rio, right? It's hot, there's beaches, there's women wearing not very much stuff all around them, right? So she goes, wait a minute, how fleece jackets? Why is pollution from fleece jackets ending up in the ocean? Are people going to the beach and rolling around in the ocean in their fleece jacket? And I said, oh my gosh, that is you have to say that's a really good question, right? You can't say anything else. You go, that's such a good question. Let me explain. And so I explained how just the process of washing your fleece jacket in your home washing machine, all those little pills and fibers, they go out, the water goes somewhere, and it goes out down the drain, and you know what? It ends up in the world's oceans. And she had this sense of like, oh my gosh, I never thought about that. I feel so stupid, but so much more educated at the same time. And so not only was I passing on that little bit of information in that moment, but if you jump forward to 2021 and you say microplastics, people have actually heard of them. And people are thinking about their fleece jackets, and you see various manufacturers starting to go back to wool because of this risk. But in 2015, it was just on the cusp of being on the radar. And, it gets on the radar because of these individual stories. She learned about that. I'm sure she told 10 of her friends how stupid she was, thinking that people are rolling around in the beach, and let me share the good news so you don't make the same mistake. And, once we all grow in that knowledge, we start to make changes in how we shop and how we wash and how we do things. And, her and her 10 friends, they didn't collect the water. I did, but that's passing on that knowledge. And so I just think that's really cool because there's so many little bits that people don't necessarily put together in terms of how the science is connected to everyday life.
Oh, thank you very much. That's so exactly. Set a scene, and of course a picture of Rio right now. I'm looking at my back bench in Cambridge in the UK. Wonderful. And Alison, have you had any sort of similar experiences, reflections that relate to citizen science?
I mean, very, very similar on point is just that, okay, we're collecting information about phytoplankton, which, how does that inform policy or changes? We're not entirely sure, but people inform policy in those changes. And so exactly like Laura says, disseminating that information and how things are connected is when the light bulb comes on for people. And so I think this is definitely a growing movement across the world. There's, citizen science associations in Europe, Africa, Asia. It's going to be more and more of the way that we come together to understand how the world's working, how it's changing, and to predict those changes as well. So, I think it's been very fun, and I've enjoyed, maybe through sharing my experiences with the people on board, but also through, maybe inspiring younger scientists and how they can think about how science is done when they get into their careers, and then if they want to conserve different aspects of the planet, then they have more of those tools available to them.
Well, I think talking of tools, I know we've been talking about polar things specifically, actually quite a lot of Antarctic discussion. I wondered, James, if you could bring up just a slide with URLs on, because we could. I'm hoping that viewers now are really enthused, and we could encourage some delving into some URLs here of additional information. So from the top, Alison, did you want to, you can flag which is which?
Yeah, if you want to learn more about what's actually happening with the Fjord Fido project, we also have a partnership up in the Arctic in Svalbard. So it's not just Antarctica. And you can follow the fjordfido.org link. We're also on social media, of course, Facebook, Twitter, Instagram. I haven't started, YouTube. And then there's the Woman Scientist is my own personal. This was, motivated initially by me not wanting to get a graduate degree and showing all of the different cool ways you could be in science with a bachelor's or going after university. What can you do without having to become an academic? And so that's where this website was started, and hopefully influencing people in how to get involved. And then those are the top two, yeah.
And yeah, I would just like to say on women, I'd like to say on the Women Scientists one that when I have friends who have girls or boys interested in science in middle school and high school, I actually direct them to Allison's blog, because it's a really good, it's just a good overview of, science isn't just a university, or Allison's journey wasn't undergrad, master's, PhD, there was a whole thing in between. And I think that's really important. So I direct people to that website.
Thank you, Laura.
For younger girls. If you want to pull it up again, James, the third link is actually the Polar Collective website. And that lists all of our current projects, hopefully getting an overhaul soon, but a great place to start if you might be traveling south to get some ideas of what sort of science you could potentially be doing. And then Allison, if you can tell about SciStarter.
Yeah, the last link, if you're not traveling to the most remote regions in the world, you can search for a project right in your own backyard. And that is what SciStarter was set up to do, to be basically like the phone book or a catalog of over 3,000 different projects that you can hopefully get involved with and see the entire spectrum that exists.
That's fantastic. And I do hope our viewers are feeling motivated. I'm feeling motivated, frankly, after having an hour chatting with you about your experiences. Really, I having run through the definitions, some examples, some philosophy, and ways in which our viewers can get involved, I do hope that you've enjoyed the conversation as much as I have. It's really just now for me to thank both our inspirational citizen science speakers. So thank you, Alison, and thank you, Laura.
Thank you, Damon.
Thank you.
And also to thank you, Viking TV viewers. Thank you for taking the time to join us in conversation at the beginning of Science Week. And we look forward to connecting with you next time.